For most of human history, the human body did not become stronger with time. In many ways, it slowly moved in the opposite direction. Compared with our closest relatives among the great apes, the average human muscle produces less raw force. Even though our bodies consume more energy to support a large brain, over hundreds of thousands of years, evolution appears to have traded something physical for something else entirely. Our ancestors did not suddenly wake up weaker, but across deep time the balance of the human body changed away from brute strength and toward other abilities that helped our species survive in different ways. The quiet question hidden inside this long transformation is simple, but unsettling. If strength once mattered so much in nature, what did humans gain by losing it? And more importantly, why did humans lose most of their strength in the first place? If a human and a chimpanzee of similar size were placed in the same physical contest, the outcome would likely surprise many people. The chimpanzee would almost certainly win. Studies comparing muscle performance suggest that chimpanzee muscles can generate more force relative to body size than human muscles. Even without exact numbers, the pattern is consistent enough for scientists to recognize a clear difference. The strange part is not that chimpanzees are strong. Many animals are strong. The strange part is that humans, despite becoming the most widespread species on the planet, did not evolve into the strongest version of themselves. In fact, the opposite appears to have happened. Compared with our closest living relatives, humans produce less explosive force in their muscles. The human body is capable of remarkable endurance and coordination, but raw strength is not where it excels. This quiet biological detail leads to an uncomfortable realization. The species that builds cities, crosses oceans, and reshapes entire ecosystems does not do so because of superior muscle power. Long before cities, agriculture, or written history existed, the human body had already begun to move in a different evolutionary direction. To understand this shift, it helps to imagine the long timeline of human ancestry stretching back millions of years. Early members of the human lineage lived in landscapes very different from the modern world. Forests, woodlands, and open savannas shaped how bodies survived and moved. In those environments, survival did not depend only on overpowering rivals. It depended on finding food, traveling across large distances, avoiding predators, and cooperating with others. Over time, these pressures slowly influenced the structure of the human body. Muscles did not disappear, and humans certainly remained capable of physical work. Yet the balance between strength, endurance, and energy use began to change. Fossil evidence shows that early human ancestors already had bodies that were adapting for upright walking. The shift toward walking on two legs changed how weight moved through the skeleton and how muscles supported the body. Instead of distributing force across four limbs, the human frame reorganized itself around balance and efficient movement over long distances. This change alone began to reshape how muscle power was used. At the same time, the human lineage was developing another unusual feature: a rapidly growing brain. Brain tissue requires a large amount of energy to maintain. Even at rest, the human brain consumes a significant share of the body's metabolic resources. Energy used for one biological function cannot easily be used for another. In evolutionary biology, this is sometimes described as a trade-off. When one system grows more complex or more demanding, other systems may adapt in different ways. Over long periods of time, the human body appears to have followed such a path. Instead of maximizing the raw force of muscle fibers, natural selection favored bodies that could support endurance, coordination, and the energetic demands of a large brain. Archaeological discoveries also hint at another quiet transformation. Early stone tools appear in the archaeological record long before agriculture or permanent settlements. A shaped stone edge could cut, scrape, or process food in ways that bare hands and teeth could not easily accomplish. Once tools entered the picture, the environment no longer responded only to muscle. A relatively small amount of force, applied through a sharp edge or a lever, could produce powerful results. Across thousands of generations, these small changes accumulated. Humans did not suddenly become weak, and they were never fragile creatures. Yet compared with many animals of similar size, including their own primate relatives, the human body gradually leaned away from pure strength and toward other capabilities. This is where the puzzle truly begins. If strength once played such a central role in survival across the natural world, why did the human lineage slowly move away from it? When people imagine survival in the natural world, they often picture strength as the decisive advantage. Large teeth, powerful jaws, heavy muscles, and the ability to overpower rivals seem like obvious tools for survival. Many animals follow this pattern. A stronger individual can defend territory, capture prey, or push competitors away from food. At first glance, it might seem logical that the most successful species would also be among the physically strongest. Yet the story of human evolution does not follow this expectation. The human body tells a different story, one that unfolds slowly across deep time. When researchers compare the muscles of humans with those of chimpanzees and other great apes, they notice consistent differences in how force is produced. Chimpanzees, for example, possess muscle structures that allow them to generate powerful bursts of strength. Their bodies are built for climbing, pulling, and sudden explosive movements through trees and branches. Even when a human is well trained, the underlying structure of human muscle does not match that same pattern of raw force. This difference is not the result of weakness in a simple sense. Instead, it reflects a different evolutionary direction. The muscles of the human body appear to be organized in a way that supports longer periods of activity rather than short bursts of overwhelming power. Endurance, balance, and coordinated movement across distance become more important than explosive strength alone. To understand why such a shift might occur, it helps to imagine the environment where early humans and their ancestors lived. Millions of years ago, parts of Africa were gradually changing. Forested areas gave way in many places to more open woodlands and savanna landscapes. In such environments, food sources were often spread far apart. Water could be distant. Predators were present. Survival sometimes required moving across wide territories rather than dominating a single small space. In a forest canopy, strong arms and powerful grips help an animal move from branch to branch. On open ground, however, a different set of abilities becomes useful. Walking and running efficiently over long distances begins to matter. The human body gradually developed features that reflect this shift. The legs lengthened relative to the arms. The feet developed arches that help store and release energy with each step. The spine balanced the body above the hips, making upright walking more stable and efficient. None of these changes were about increasing brute force. They were about conserving energy while moving through large landscapes. Fossils from early human ancestors reveal bones that suggest regular upright walking was already present long before modern humans appeared. These skeletal clues indicate that the transition toward efficient bipedal movement happened gradually over long periods. Each generation inherited small variations that either helped or hindered survival in the environment around them. Over time, bodies that used energy more efficiently while traveling long distances were more likely to succeed. This slow adjustment influenced how muscles were used. Instead of concentrating on maximum power, the body increasingly supported sustained activity. Walking, tracking animals, gathering plants, and carrying resources all benefited from endurance. In such a context, strength still mattered, but it was no longer the only path to survival. Another quiet change may also have been unfolding at the same time. As early humans began to explore wider landscapes, they rarely did so alone. Small groups moved together across terrain, sharing knowledge about food sources, water, and danger. Cooperation reduced the need for each individual to rely solely on personal strength. A group working together could accomplish tasks that no single body could manage alone. These early patterns of movement and cooperation did not immediately erase strength from the human body. Muscles remained essential. Yet the balance of traits favored by natural selection began to tilt in another direction. Across thousands of generations, the human body slowly shaped itself into a creature built less for overpowering the world and more for navigating it over time. The deeper question is not simply why humans became less powerful in their muscles. The deeper question is why evolution allowed such a shift to happen at all. For a long time, it was easy to assume that the human body had simply become weaker through history. Compared with many animals, and even compared with other great apes, the human frame does not appear especially powerful. The arms are shorter relative to the legs. The chest and shoulders are shaped differently from those of tree-climbing primates. Muscle mass is present, but it is not arranged for explosive bursts of force in the same way. Yet when scientists look closely at the human body, they do not see a failed design. Instead, they see a body organized around a different set of priorities. Human muscles are capable of working for long periods without exhausting themselves quickly. The heart and lungs support sustained activity across hours rather than moments. The structure of the legs, feet, and tendons allows energy to be stored and released with each step during walking and running. These details suggest that the human body was gradually shaped for persistence rather than domination through force. One way to understand this transformation is to imagine the daily rhythm of early human life. Long before cities or agriculture existed, people lived by gathering plants, searching for edible roots, tracking animals, and moving between seasonal resources. These activities required time and distance. A group might travel across open landscapes for many hours in a single day. The success of such movement depended less on how hard a muscle could pull in a single instant, and more on how efficiently the body could keep moving without stopping. In this environment, endurance quietly becomes a form of strength. A creature that can continue moving after others must rest gains access to resources spread across large territories. Evidence from anthropology and biology suggests that early humans may have used persistence hunting in some situations. This strategy involves tracking an animal over long distances, allowing heat and fatigue to gradually slow the prey. The human body, with its ability to sweat efficiently and maintain steady movement, may have supported this kind of activity under certain conditions. Even if such hunts were not constant events, the physiological traits associated with endurance would still have provided advantages across everyday life. The body that could walk farther and longer could reach food sources that others might never find. As these patterns repeated across generations, the physical profile of the human lineage continued to shift. Muscle fibers themselves show subtle differences between humans and other apes. Research suggests that human muscles contain a larger proportion of fibers associated with sustained activity, while other primates often show a structure better suited for rapid bursts of strength. This difference does not make one species superior to another. It simply reflects different solutions to different ecological challenges. The chimpanzee's powerful pull helps it move through dense forest canopies. The human body's balance between endurance and coordination supports movement across open ground and complex landscapes. Another quiet change was unfolding alongside these physical adjustments. As human ancestors became more skilled at using tools, the relationship between muscle and environment began to shift. A shaped stone, a wooden spear, or a digging stick could multiply the effect of modest force. Instead of relying solely on muscle power, humans could direct energy through objects designed for specific tasks. A cutting edge could process meat or plant fibers with far less effort than teeth or hands alone. Over time, the role of muscle began to share space with the role of technology, even in its earliest forms. This does not mean that humans abandoned strength. Carrying food, climbing, building shelters, and defending against danger still required physical ability. Yet the body no longer had to win every contest through direct force. Intelligence, cooperation, endurance, and simple tools began to share the burden of survival. The human body was gradually becoming something unusual in the natural world, a creature that relied less on overpowering its surroundings and more on adapting to them. Seen from this perspective, the apparent loss of strength may not be a simple loss at all. It may be part of a larger exchange that unfolded across millions of years of human history. To understand why the human body no longer emphasizes raw strength in the same way as other primates, it helps to look much further back than the appearance of modern humans. The story begins deep in the evolutionary history of primates, long before the first members of the human lineage walked across open landscapes. Early primates evolved in environments dominated by trees. Dense forests covered large regions of the planet, creating a world where survival often depended on movement above the ground. In such environments, bodies adapted to climbing, gripping, and balancing among branches. Arms became strong and flexible. Hands developed grasping fingers capable of wrapping around wood and vines. Shoulders gained wide ranges of motion, allowing animals to swing, pull, and support their body weight while suspended. These features are still visible in many primates today. Chimpanzees, gorillas, and orangutans all carry traces of this arboreal past in their anatomy. Their arms are long and powerful relative to their legs. Their shoulders are structured to support hanging and climbing. Their hands can grip with remarkable strength. These adaptations are extremely effective in a forest canopy, where reaching the next branch may require sudden bursts of pulling power. The human body, however, still carries only partial remnants of this ancient design. Our hands remain capable of grasping objects with precision. Our shoulders retain some of the mobility inherited from tree-dwelling ancestors. Yet other parts of the body tell a different story. The proportions between arms and legs have changed dramatically. Human legs are longer relative to the arms than in most other primates. The pelvis and spine have shifted to support upright posture. The feet have lost the grasping ability that many primates still use to hold branches. These differences suggest that the human lineage slowly moved away from a life spent primarily in trees. Fossil discoveries provide clues about when these changes began to appear. Some of the earliest known ancestors connected to the human branch already show signs of adapting to movement on the ground. Their bones indicate that climbing remained part of their behavior, but upright walking was becoming more common. This combination suggests a long transition rather than a sudden transformation. For many generations, early members of the human lineage likely divided their time between trees and ground. Each environment favored different physical abilities. Climbing rewarded powerful arms and gripping strength. Walking across land favored balance, endurance, and efficient leg movement. Over time, these pressures gradually reshaped the body. As life on the ground became more important, the structure of the skeleton slowly reorganized around upright walking. The position of the head shifted to balance above the spine. The hips widened to support the weight of the body while standing. The legs lengthened and strengthened to carry the body forward step after step. Meanwhile, the arms no longer needed to support the entire weight of the body during movement. Their role began to change. Instead of constantly pulling and climbing, the arms became increasingly free for other activities. Hands that once gripped branches could now carry objects, manipulate materials, and eventually shape tools. This change did not remove strength from the arms entirely, but it altered how that strength was used. Rather than focusing on lifting the entire body through trees, human arms became part of a broader system involving coordination, precision, and interaction with the surrounding environment. These early anatomical shifts did not make the human lineage weak. In fact, the bodies of early humans were likely well suited to the demands of their environment. However, the balance between upper body strength and lower body movement had begun to change. As generations passed, the structure inherited from tree-dwelling ancestors slowly gave way to a body built for life on the ground. The deeper implication of this shift is subtle, but important. The human lineage did not simply lose strength without reason. Instead, it inherited a body shaped for one environment and gradually transformed it to function in another. In doing so, certain abilities became less central while others became more important. The strength that once dominated life in the trees was no longer the primary advantage on open ground. The question that remains is how far this transformation eventually went, and what new abilities began to replace the physical power that earlier primates relied upon. The forest canopy where early primates lived was not simply a collection of trees. It was a complex three-dimensional world where every movement required careful control of the body. Branches varied in thickness and strength. Some could support full body weight, while others bent or broke under pressure. Moving through this environment demanded a combination of grip strength, balance, and quick adjustments of the limbs. For primates that lived almost entirely in trees, powerful upper bodies were not optional. They were essential. A strong pull of the arms could lift the entire body toward a higher branch. Fingers and thumbs wrapped tightly around bark and vines, preventing a fall that could be fatal. The shoulders of these animals evolved to rotate freely, allowing arms to reach overhead, behind, and to the side with ease. In this setting, bursts of strength played a major role in daily life. Climbing, swinging, and stabilizing the body often required sudden force produced in short moments. The muscles of chimpanzees and other great apes still reflect this heritage. Their bodies are compact and powerful, with large muscles concentrated around the shoulders and arms. Even their skeletal structure supports these movements. The shoulder blades are positioned in a way that helps distribute force when pulling the body upward or hanging from branches. The human skeleton tells a different story. While the shoulders remain flexible, the entire upper body is less specialized for constant climbing. The arms are shorter relative to the legs. The the chest is shaped differently, and the overall distribution of muscle mass has shifted. These features do not prevent humans from climbing entirely, but they suggest that climbing is no longer the central activity shaping the body. Instead, the most powerful muscles in the human body are found in the legs and hips. These muscles drive walking and running. They support the weight of the body during upright movement and help maintain balance while traveling across uneven terrain. The shift from arm-dominated movement to leg-dominated movement marks a significant transition in the evolutionary path of the human lineage. This transition likely did not happen quickly. Early ancestors may have spent long periods living partly in trees and partly on the ground. Some fossils show curved finger bones that suggest climbing abilities were still important. At the same time, other parts of the skeleton reveal adaptations for upright walking. This mixture of traits indicates that the human lineage experienced a gradual shift rather than a sudden break from its arboreal past. As time passed and open environments expanded in parts of Africa, the advantages of efficient ground movement became more pronounced. Individuals who could travel farther with less energy may have had better access to scattered food sources. Walking upright freed the hands to carry objects, gather resources, and interact with tools. The arms, no longer responsible for supporting the entire body during movement, became available for tasks that required precision and coordination. This quiet change in function had consequences for muscle development. When a body no longer depends heavily on explosive pulling strength to survive, natural selection may place less emphasis on maintaining that level of power. Instead, other features begin to take priority. Energy efficiency, balance, and fine motor control slowly become more valuable. The human body appears to have followed this path over many generations. Muscles remained capable, but their organization reflected new demands. The strength once used for climbing high into trees gradually became less central to survival. At the same time, the human lineage was developing abilities that no other primate had used in quite the same way. Hands capable of precise grips allowed early humans to shape stone edges and wooden tools. These tools did not replace the need for muscles, but they changed how muscles interacted with the world. Instead of relying only on the force of the body itself, humans could apply smaller amounts of force through carefully shaped objects. This development slowly altered the relationship between strength and survival. The physical power that once dominated life in the trees began to share space with new strategies emerging on the ground. The transformation was gradual and subtle, unfolding across thousands of generations. Yet by the time modern humans eventually appeared, the balance of the body had already shifted far from its arboreal origins. Even after early members of the human lineage began spending more time on the ground, the influence of their arboreal past did not disappear immediately. Evolution rarely erases old traits overnight. Instead, it works slowly, modifying existing structures across many generations. This means that the early ancestors of humans likely carried a body that still remembered life in the trees while gradually adapting to a new way of moving through the world. Fossil bones provide small but meaningful clues about this transition. Some early hominin skeletons show curved finger bones, a shape often associated with climbing and gripping branches. At the same time, the pelvis and legs reveal adaptations for upright walking. These mixed signals suggest that early humans were not entirely separated from their tree-dwelling past. They may have climbed when necessary, slept in trees for safety, or used elevated areas to observe the surrounding landscape. Yet the direction of change was already becoming clear. Over time, the body was reorganizing around a different center of gravity. In animals that spend most of their lives in trees, the upper body carries much of the responsibility for movement. Powerful arms pull the body upward, while flexible shoulders allow rapid adjustments in position. In contrast, the human body gradually shifted this responsibility downward. The legs became the primary drivers of movement, supporting the body for long periods of walking across open ground. This redistribution of effort changed how muscles were used. When arms are no longer required to lift and swing the entire body through trees, the evolutionary pressure to maintain extreme upper body strength becomes weaker. Muscles remain present, but their role evolves. Instead of constantly pulling body weight upward, the arms increasingly assist with balance, carrying objects and interacting with tools. The hands, in particular, began to take on a more delicate and precise function. The human thumb, capable of opposing the fingers, allowed a level of control over objects that few animals possess. This ability did not depend on raw strength alone. It depended on coordination, sensitivity, and the careful control of small muscles. The shift toward precision gradually made the human hand one of the most distinctive features of our species. At the same time, the lower body continued to adapt to the demands of upright movement. The structure of the foot changed in ways that reflect long-distance walking. Instead of spreading toes used for gripping branches, the human foot developed a stable platform for supporting body weight. The arch of the foot helps absorb and release energy with each step, reducing the cost of movement across large distances. These changes made travel across open landscapes more efficient. Efficiency, in evolutionary terms, can be just as important as strength. A creature that spends less energy moving from place to place can survive longer when food is scarce. Over many generations, small advantages in energy use accumulate into significant differences in survival. The human body appears to have followed this principle. Rather than maximizing muscular force, it gradually optimized the ability to move steadily through complex environments. This does not mean early humans abandoned strength altogether. Climbing, lifting, and defending against danger still required physical power. However, the balance of abilities was changing. Strength was becoming one element among many, rather than the dominant trait shaping the body. As this transition continued, another factor began to influence the course of human evolution. The increasing use of tools allowed individuals to interact with the environment in new ways. A simple stone edge could cut through plant fibers or animal hide with far less effort than teeth or bare hands. A stick could extend the reach of the arm. These tools did not eliminate the need for muscles, but they altered the relationship between muscle and environment. Over time, this relationship would become one of the defining features of human survival. By the time the earliest members of our species appeared, the transformation that began in the trees had already reshaped the human body. The powerful climbing arms of ancient primates had gradually given way to a body designed for endurance, coordination, and interaction with tools. What once defined survival in the forest canopy had slowly faded in importance on the ground. Yet the story does not end with the body alone. The deeper transformation would soon involve the way humans used energy, cooperation, and intelligence to survive in landscapes far larger than any single individual could dominate. Long before cities, agriculture, or written language appeared, one quiet transformation had already begun to reshape the human body. The ancestors of humans started to walk upright. At first glance, this change might seem simple. Walking on two legs instead of four may appear to be only a different style of movement. Yet in evolutionary terms, it represents one of the most significant shifts in the entire story of the human lineage. When a body stands upright, the forces acting on it change completely. Gravity, which once pulled the body forward onto four limbs, now presses downward through the spine and hips. Balance must be maintained in a new way. The skeleton reorganizes itself to keep the head stable above the body. The spine curves slightly to absorb impact. The pelvis widens and reshapes to support the weight of internal organs while standing. These changes did not occur suddenly. Fossil discoveries suggest that upright walking developed gradually across long stretches of time. Early ancestors may have walked upright part of the time while still using trees for safety or food. Over generations, however, the ability to move efficiently on two legs became more pronounced. This shift changed how energy moved through the body. In animals that walk on four limbs, the weight of the body is distributed across both the front and rear legs. Muscles in the shoulders and arms play a large role in movement. In contrast, upright walking places most of the responsibility on the lower body. The hips, thighs, and calves begin to carry the majority of the work. As the legs become the primary engines of movement, the arms are gradually freed from supporting the body during travel. This freedom had consequences that went far beyond posture. Once the arms no longer needed to carry the body forward step by step, they could be used for other purposes. Hands could gather food, carry objects, and interact with materials in the environment. The shoulder joint retained its wide range of motion, but its function slowly shifted away from constant weight-bearing movement. At the same time, the muscles of the lower body grew more important. Walking upright requires a coordinated system of muscles working together with bones and tendons. Each step stores and releases small amounts of energy through the legs and feet. This efficiency allows the body to travel long distances without exhausting itself too quickly. Researchers studying human locomotion often point out that upright walking is remarkably energy efficient compared with many other forms of movement. Over long distances, the human body can cover ground using relatively little energy. In environments where food and water may be spread far apart, such efficiency becomes a powerful advantage. However, this advantage comes with trade-offs. When the body evolves to move efficiently over distance, it may not emphasize explosive strength in the same way. The muscles of the legs are strong, but their strength is used repeatedly across thousands of steps rather than concentrated in a single powerful motion. Meanwhile, the upper body is no longer specialized for lifting the entire body through trees or branches. As generations passed, the structure of the human body slowly reflected these priorities. The legs lengthened relative to the arms. The foot developed a rigid structure capable of supporting the body during long walks. The spine balanced the head and torso above the hips. All of these features supported upright movement across open terrain. None of them were designed to maximize raw pulling power in the arms. From a distance, this transformation might look like a loss of strength. In reality, it was part of a deeper reorganization of the body's abilities. The human lineage was gradually becoming a creature designed to travel, observe, and interact with the world in ways that no other primate had done before. Yet even this remarkable shift raises another question. If walking upright freed the hands and changed the structure of the body, what new roles would those hands eventually take on in the long journey of human evolution? Once upright walking became more common among the ancestors of humans, the entire rhythm of movement began to change. On four limbs, the body moves in a pattern where the front and rear limbs share the effort of supporting weight and pushing forward. The muscles of the shoulders and arms remain deeply involved in the act of moving from place to place. But when a body rises onto two legs, that pattern disappears. The arms are no longer part of the engine that propels the body across the ground. Instead, they hang at the sides, free from the constant duty of locomotion. This change may seem small, but it quietly altered the evolutionary pressures acting on the human body. Muscles develop and remain strong when they are used frequently for essential tasks. When a part of the body becomes less central to survival, the intensity of those pressures may gradually decrease. As the lower body took on the responsibility of movement, the upper body entered a different phase of evolution. The arms were no longer required to support the body during every step. They still played roles in balance and climbing when necessary, but their constant workload had diminished. Over many generations, this shift could influence how muscle strength was maintained and distributed throughout the body. The human legs, by contrast, became central to survival. Each step during walking or running required the coordinated effort of multiple muscle groups. The large muscles of the thighs pushed the body forward. The hips stabilized the torso above the legs. The calves and feet absorb impact and help propel the body into the next stride. These muscles work repeatedly, sometimes for hours during a single day of movement. Their strength is expressed through endurance rather than sudden bursts of power. The human foot also reveals how deeply upright movement reshaped the body. Unlike the flexible feet of many primates, which are capable of grasping branches, the human foot forms a stable structure designed for supporting body weight. The arch of the foot acts like a spring, storing small amounts of energy during each step and releasing it as the body moves forward. This design allows the body to move efficiently across long distances without exhausting itself quickly. Efficiency became increasingly important as early humans moved through environments where resources were scattered. Food, water, and shelter were rarely located in a single fixed place. Instead, groups often traveled across wide territories while searching for plants, animals, or safe resting areas. The ability to move steadily through such landscapes provided clear advantages. A body capable of covering ground efficiently could explore larger areas and respond more flexibly to changing conditions. This emphasis on movement across distance also influenced how energy was used inside the body. Muscles that operate repeatedly over long periods rely on different physiological strategies than muscles built for explosive strength. They must balance power with efficiency, conserving energy while still maintaining steady output. The human body appears to have evolved with this balance in mind. While other primates retained the muscular systems needed for climbing and pulling with great force, the human lineage gradually emphasized traits that supported persistence and coordination. At the same time, upright posture created new possibilities for interaction with the environment. With the hands no longer required to support locomotion, they became available for tasks that had little to do with walking itself. Early humans could carry gathered food, transport tools, or hold objects while traveling. Even simple activities such as throwing or digging became easier when the body was balanced above two legs and the arms were free to move independently. These changes did not happen instantly. Evolution works slowly, shaping bodies across countless generations, but the direction of change was clear. The center of movement had shifted from the arms to the legs, and with that shift came a gradual transformation in how strength functioned within the human body. The question that remains is what happened once the hands were fully freed from the task of locomotion. Over time, those hands would begin to shape the environment in ways that no other animal had done before. As upright walking became a stable feature of the human lineage, its effects spread quietly through many aspects of the body. The change was not limited to posture or movement alone. Once the body balanced itself above two legs, the relationship between muscles, bones, and daily activity began to reorganize in subtle ways. The arms, now released from the continuous work of locomotion, entered a new phase of evolutionary possibility. Instead of constantly supporting body weight, they could move more freely through space. This freedom encouraged a different kind of physical ability, one that emphasized control rather than sheer force. The human shoulder retained a wide range of motion inherited from climbing ancestors, but its purpose gradually shifted. Instead of pulling the body upward through branches, the shoulder allowed the arm to swing, reach, and manipulate objects with accuracy. The elbow and wrist added further precision, guiding the hand into positions that required careful coordination. The hand itself became one of the most distinctive features of the human body. While many primates possess strong gripping hands, the human hand developed a refined balance between strength and dexterity. The thumb could press firmly against the fingers, creating a powerful but controlled grip. This ability made it possible to hold small objects securely and adjust their position with fine movements. Such precision was not designed for climbing alone. It opened the door to interactions with the environment that relied on subtle control rather than overwhelming force. At the same time, the lower body continued to strengthen its role as the foundation of movement. Walking upright places the body's weight above the hips, and each step requires the legs to absorb impact and push the body forward again. The muscles of the thighs and hips became especially important in this process. These muscles are among the largest in the human body, capable of generating steady power across repeated steps. The strength they provide is not always dramatic in a single moment, but over time it allows humans to travel remarkable distances. This pattern of movement shaped daily life for early humans. Food gathering, exploration, and seasonal movement often required hours of walking across varied terrain. In such conditions, the ability to sustain activity over time could be more valuable than the ability to deliver a single powerful motion. Endurance slowly became one of the defining features of the human body. While other animals excelled in bursts of speed or strength, humans developed a capacity for persistence that supported their survival across wide landscapes. Yet the transformation of the arms remained just as significant. Freed from constant locomotion, the hands became tools in their own right. Early humans could grasp stones, shape edges, and manipulate materials with growing skill. Even simple actions such as turning an object, striking one stone against another, or carrying items across distance depended on the coordination between the brain, hands, and eyes. Over time, these actions grew more refined. The human body was gradually evolving into a system where physical strength alone was no longer the central factor determining success. Instead, success increasingly depended on how effectively the body could coordinate movement, perception, and interaction with the environment. The arms did not need to overpower branches or rivals with raw force. They needed to guide tools, carry resources, and respond flexibly to changing situations. Seen from this perspective, the apparent reduction in upper body strength becomes easier to understand. As the demands of locomotion shifted to the legs, and the demands of survival expanded beyond brute force, the role of muscle power began to change. Strength remained present, but it was integrated into a broader system of endurance, coordination, and manipulation. This quiet reorganization of the body would eventually support abilities far beyond movement alone. In the long story of human evolution, walking on two legs did more than change posture. It created the conditions for hands to become instruments of interaction with the world, setting the stage for the next transformation in how humans survived. When people think about physical ability in animals, strength is often the first quality that comes to mind. Images of powerful predators or muscular primates easily dominate the imagination, yet strength is only one way a body can survive in nature. Another strategy, less dramatic but equally effective, is endurance. Instead of overpowering the environment in a single moment, a body can outlast challenges over time. In the long evolutionary history of humans, this second strategy appears to have become increasingly important. The human body shows many signs of being adapted for sustained activity rather than short bursts of overwhelming force. This difference can be observed in how muscles operate. Some muscles are designed for explosive power, capable of producing large amounts of force in a very brief moment. Others are organized to support repeated movement over longer periods. Human muscles tend to favor the latter pattern more than those of our closest primate relatives. This does not mean that humans lack strength entirely, but it suggests that the body places greater emphasis on endurance and stability. One of the most visible clues lies in the human ability to move steadily across long distances. Walking is a simple action, yet humans can perform it for hours without stopping. The design of the legs, hips, and feet helps conserve energy with each step. Tendons store small amounts of elastic energy and release it again as the foot leaves the ground. This reduces the muscular effort required to keep moving forward. Over many thousands of steps, these small efficiencies accumulate into a significant advantage. Running also reveals an unusual aspect of the human body. Humans are not the fastest animals in short sprints. Many animals can outrun a person easily over a brief distance. However, the human body possesses features that support longer periods of running. The ability to regulate body temperature through sweating, the balance provided by upright posture, and the coordination of muscles in the legs all contribute to sustained movement. These traits do not produce the most powerful burst of speed, but they allow the body to keep going long after a sprinting animal must slow down. Anthropologists have suggested that early humans may have sometimes relied on persistence when pursuing animals across open landscapes. Instead of overpowering prey immediately, hunters could follow an animal at a steady pace, allowing fatigue and heat to gradually weaken it. This strategy would require patience and endurance rather than explosive strength. Whether used frequently or only occasionally, the physiological traits that support such activity still reflect a body adapted for sustained effort. Even outside of hunting, endurance offered advantages in daily survival. Gathering food, traveling between seasonal resources, and exploring new territory all demanded the ability to move for extended periods. A group capable of traveling farther could reach places that others might never find. In such environments, the ability to continue moving while conserving energy could shape the outcome of survival over many generations. This emphasis on endurance did not eliminate strength from the human body. Muscles remained necessary for carrying objects, climbing when needed, and responding to danger. However, the role of strength gradually shifted. Instead of focusing on overwhelming force in a single moment, the human body distributed its effort across longer spans of time. Strength became part of a larger system designed to support persistence. When viewed across the deep timeline of human evolution, this pattern begins to reveal a subtle exchange. The human lineage may not have simply lost strength. It may have traded some forms of explosive power for the ability to move, work, and endure across landscapes that stretched far beyond the reach of a single sprint. The question that emerges from this exchange is quiet but profound. If endurance gradually became one of the defining traits of the human body, what other abilities began to develop alongside it as humans adapted to life in a changing world? If endurance played a growing role in the survival of early humans, the human body would need a structure capable of supporting repeated movement over long periods of time. When researchers examine the anatomy of humans with this question in mind, they begin to notice a pattern of features that quietly support sustained activity. None of these features appear dramatic when viewed alone, yet together they form a system that allows the body to continue moving long after many animals would have been forced to stop. One of the most important of these features lies in how the human body regulates heat. Most mammals rely heavily on panting to release excess heat generated during activity. Panting works well during brief bursts of movement, but it becomes less effective during long periods of running or walking. The human body, by contrast, uses sweating as its primary method of cooling. Sweat evaporates from the skin, carrying heat away from the body. This process allows humans to continue moving while maintaining a relatively stable internal temperature, even under warm conditions. Such cooling does not make humans the fastest animals in the natural world, but it does support longer periods of sustained effort. Over time, this ability to manage heat could allow a human to remain active during parts of the day when other animals might need to rest. The body's structure also contributes to this capacity for endurance. The human head balances above the spine in a way that reduces the effort required to keep it stable while moving. A network of muscles and ligaments helps keep the head from tilting forward during walking and running. This stability allows the eyes to remain focused on the environment while the body moves. It is a small detail, but it plays a role in allowing humans to travel across uneven ground without constantly struggling to control their posture. The human torso also shows signs of adaptation for sustained movement. The rib cage and lungs work together to support steady breathing during activity. As the body moves, breathing patterns can adjust to match the rhythm of movement, supplying oxygen to muscles that continue working over long distances. This steady exchange of oxygen helps muscles maintain their activity without quickly exhausting their energy reserves. Beneath the skin, the arrangement of muscles and tendons reflects similar priorities. Tendons in the legs can store elastic energy when the foot strikes the ground. As the body pushes forward into the next step, that stored energy helps propel movement with less muscular effort. This process does not produce explosive power, but it makes repeated steps more efficient. Over thousands of steps in a single day, the savings in energy become significant. Such features may not appear impressive when compared with the dramatic strength of animals built for short bursts of force. A chimpanzee pulling itself upward through branches demonstrates obvious muscular power. A human walking steadily across open ground appears less dramatic, yet endurance operates quietly. Its advantages reveal themselves only over time. The body that can continue moving while others must rest slowly gains access to more territory, more resources, and more opportunities for survival. This pattern may help explain why the human lineage did not evolve toward maximum strength in the upper body. Instead of competing through direct displays of force, humans increasingly relied on movement, patience, and persistence. Strength remained part of the body's abilities, but it no longer defined the entire strategy of survival. Over many generations, the traits that supported endurance became deeply integrated into the structure of the human body. However, endurance alone cannot explain the entire transformation of human strength. The body was changing in other ways as well, especially in how energy was used inside the organism. As the human lineage continued to evolve, another demanding organ was quietly expanding its influence over the body's resources. Endurance is not always easy to recognize because it rarely appears in dramatic moments. Strength can be seen instantly when a body lifts, pulls, or overpowers something in front of it. Endurance, however, reveals itself slowly. It appears in the ability to continue moving long after fatigue begins to settle in. It appears in the capacity to repeat the same action again and again without collapsing from exhaustion. For much of human evolutionary history, these quiet qualities may have mattered more than sudden bursts of force. When scientists examine the muscles of humans and compare them with those of other primates, they find differences that support this idea. Muscle fibers can vary in how they produce energy and force. Some fibers generate powerful contractions but fatigue quickly. Others produce less immediate force but can continue working for longer periods. Human muscles tend to include a greater balance toward fibers suited for sustained activity. This structure does not eliminate strength, but it spreads muscular effort across longer stretches of time. In contrast, the muscles of many climbing primates emphasize explosive pulling strength. Such power helps them swing through branches or climb vertical surfaces rapidly. The environments that shaped those bodies rewarded sudden force. The environments that shaped the human lineage may have rewarded persistence instead. Imagine a group of early humans moving through open terrain. The sun rises slowly over a wide landscape. Food is not concentrated in one location. Edible plants must be searched for across hills and valleys. Animals move across large territories, often following seasonal patterns. In such a world, survival may depend less on overpowering a single obstacle and more on continuing the search hour after hour. The group that can keep moving steadily across the land may discover resources that others never reach. Anthropological research suggests that early human societies often organized their daily lives around movement. Small groups traveled through familiar territories, gathering plants, tracking animals, and sharing information about water sources or safe resting places. These journeys could last many hours in a single day. The body that could support such movement without quickly exhausting its energy reserves would hold a clear advantage. Over long periods of time, even small differences in endurance could influence which individuals successfully found food or returned safely to their group. Another factor also supported this pattern of persistence. Humans developed an unusual ability among mammals, the capacity to sweat efficiently across large areas of the skin. As sweat evaporates, it removes heat generated by working muscles. This process allows the body to continue moving in warm conditions without overheating as quickly as animals that rely primarily on panting. While sweating does not produce strength in the traditional sense, it allows the body to sustain effort across longer periods of activity. This cooling system works quietly in the background, supporting the rhythm of steady movement. Taken together, these traits form a picture of a body designed not for dramatic displays of power, but for patient persistence. The muscles, tendons, and cooling systems of the human body cooperate to support movement across long distances and extended periods. In such a system, explosive strength becomes only one part of the overall design. The deeper advantage lies in the ability to continue when others must stop. Seen in this light, the apparent loss of muscular power begins to look less like a weakness and more like a shift in strategy. Evolution did not simply remove strength from the human body. Instead, it reorganized how strength was expressed, distributing effort across time rather than concentrating it in a single moment. Yet endurance alone does not explain the full story. Another transformation was unfolding within the human body, one that demanded enormous amounts of energy and gradually reshaped how the body allocated its resources. Inside the human body, every organ competes quietly for energy. The food consumed each day must be divided among muscles, organs, and the countless biological processes that keep the body alive. Evolution cannot give unlimited energy to every system at once. When one part of the body becomes more demanding, others must adjust. This balance is one of the central principles of biology. In the story of human evolution, one organ gradually began to demand more energy than any other. That organ was the brain. Compared with most animals of similar body size, humans possess unusually large brains. Brain tissue is metabolically expensive. Even when the body is resting, the brain continues to consume a substantial share of the body's available energy. Nerve cells must maintain electrical signals, process sensory information, and coordinate movement and thought. All of this activity requires a steady supply of fuel. Over the long course of human evolution, the growth of the brain may have created a new pressure on how energy was distributed throughout the body. When energy resources are limited, increasing the demand of one system can influence the development of others. Researchers studying human evolution sometimes describe this situation as a biological trade-off. In such trade-offs, natural selection does not necessarily produce bodies that maximize every possible trait. Instead, it shapes bodies that balance competing demands in ways that support survival in a specific environment. In the human lineage, the expanding brain may have required adjustments elsewhere in the body's energy budget. Muscles, while still essential, may not have remained the primary focus of evolutionary investment. This idea does not mean that muscles simply became weak. Humans still possess strong muscles capable of performing demanding work. However, the balance between brain and muscle appears to have shifted. A body supporting a large and active brain might benefit more from endurance, coordination, and efficient movement than from maintaining extreme levels of raw muscular power. Evidence from biology supports the idea that the human brain grew significantly during the later stages of human evolution. Fossil skulls show gradual increases in brain volume across different ancestral species. At the same time, other aspects of the body were also changing. Diets were evolving, tools were becoming more sophisticated, and social cooperation was becoming increasingly important. All of these developments interacted with the growing complexity of the brain. A larger brain does more than process information. It changes how a species interacts with its environment. Early humans with improved cognitive abilities could remember locations of seasonal resources, recognize patterns in animal movement, and communicate knowledge within their group. Such abilities may have reduced the need for individuals to rely solely on physical force when solving problems in their environment. Instead of overpowering obstacles directly, humans could observe, plan, and adapt their behavior. This shift in strategy may have gradually influenced the role of strength in survival. A powerful body remains useful, but intelligence can sometimes achieve the same goal with less energy. A stone shaped into a cutting tool can accomplish tasks that would otherwise require greater muscular effort. A coordinated group using knowledge and cooperation can overcome challenges that no individual could face alone. Over time, these new strategies may have reshaped how energy was invested in the human body. The muscles still needed to function effectively, but they no longer carried the full burden of survival. Part of that burden had moved to the brain. Seen from this perspective, the apparent reduction in raw strength among humans may reflect a deeper evolutionary exchange. Energy that once supported greater muscular force may have helped sustain the growing complexity of the human mind. Yet this exchange was not simple or immediate. The relationship between brain, body, and environment unfolded slowly across many generations. Understanding that relationship requires looking more closely at how energy flows through the human body and how evolution manages the constant balance between its competing demands. The human brain does not simply grow larger during evolution without consequences. Every increase in complexity carries a biological cost. Nerve cells require constant energy to maintain electrical signals, communicate with one another, and process the information that flows through the nervous system. Even during sleep, the brain remains active, regulating breathing, monitoring the body, and organizing memories formed during the day. Because of this continuous activity, the brain draws a steady supply of energy from the body's metabolism. For early humans living in unpredictable environments, energy was never guaranteed. Food had to be found, gathered, or hunted. Periods of abundance could be followed by days of scarcity. In such conditions, the body needed to allocate its energy carefully among competing systems. Muscles, digestive organs, immune defenses, and the brain all required fuel to function. If one system grew more demanding, others might gradually adjust in response. This balancing process does not happen consciously. It unfolds slowly across generations through the quiet pressures of natural selection. Individuals whose bodies managed energy more efficiently were more likely to survive long enough to reproduce. Over time, traits that help balance the body's internal economy became more common in the population. The expanding brain of the human lineage may have been one of the factors influencing this internal balance. Compared with many other animals, humans maintain a brain that consumes a noticeable portion of the body's daily energy supply. Supporting such an organ requires reliable access to food and efficient use of metabolic resources. If the body were to maintain extremely powerful muscles while also supporting a large brain, the total energy demand could become difficult to sustain in environments where food was unpredictable. Evolution, therefore, tends to favor solutions that distribute energy in ways that support overall survival rather than maximizing every physical trait. One possible outcome of this process is a body that emphasizes efficiency and endurance rather than extreme muscular force. Muscles capable of sustained work may require less constant metabolic investment than muscles built primarily for explosive strength. This difference may appear subtle, but across long evolutionary timescales it can shape how bodies are organized. Another important factor involves the relationship between the brain and coordination. A larger brain allows more precise control over movement. Muscles do not operate independently. They respond to signals from the nervous system. As neural control becomes more sophisticated, the body can accomplish tasks with greater accuracy and less wasted effort. Instead of relying on overwhelming force, a coordinated movement guided by the brain may achieve the same result with less energy. Early humans likely benefited from this improved coordination in many aspects of daily life. Crafting tools required careful control of the hands. Tracking animals demanded attention to subtle patterns in the environment. Cooperative activities such as group hunting or resource sharing depended on communication and planning. Each of these behaviors placed demands on the brain while reducing the need for direct physical dominance over the environment. The relationship between brain and muscle is therefore not a simple competition. Muscles still require neural guidance to function effectively, and the brain depends on the body to move, gather food, and interact with the world. However, the growing influence of the brain may have shifted the balance of priorities within the body. Instead of investing heavily in raw muscular strength, the human lineage may have favored traits that allowed intelligence, coordination, and endurance to work together. This subtle shift would not necessarily make humans fragile. The body remained capable of carrying loads, traveling across long distances, and responding to physical challenges. Yet the strategy of survival was changing. The emphasis was moving away from brute force and toward a combination of physical ability and cognitive skill. As this process continued, another factor began to reinforce the transformation. The more humans relied on tools and shared knowledge, the less survival depended on the raw strength of a single individual. As the brain of the human lineage continued to grow in complexity, its influence extended far beyond thought alone. A larger and more capable brain changed how the body interacted with the environment. Instead of responding only through instinct or immediate force, early humans could rely on memory, planning, and shared knowledge. These abilities slowly transformed the way survival problems were approached. In many situations, intelligence could reduce the need for direct physical strength. Consider a simple example from early human life. Finding food in a landscape that changes with seasons requires more than muscle. Plants appear and disappear depending on rainfall and temperature. Animals migrate, hide, or change their behavior. A body that relies only on strength may struggle in such a dynamic environment. But a brain capable of remembering where food was found in previous seasons can guide the body more efficiently. Knowledge becomes a form of survival energy, allowing the body to conserve effort rather than waste it searching blindly. Over generations, this relationship between knowledge and energy efficiency may have influenced how natural selection shaped the human body. When intelligence allows a species to solve problems with planning and coordination, the environment does not always demand maximum physical strength from every individual. Instead, survival becomes a combination of physical ability and cognitive skill. The body still needs muscles, but it may not need the extreme muscular force seen in animals that rely primarily on direct physical competition. The growing role of the brain also affected how humans interacted with one another. Social cooperation became an important part of survival. A group sharing knowledge about food sources, water locations, and safe routes through the landscape could function more effectively than individuals acting alone. Communication allowed experiences to be passed from one generation to the next. What one person learned about the environment could benefit many others. This shared knowledge reduced the need for each individual to solve every problem independently through physical effort. Instead of relying on the strongest individual in the group, survival could depend on coordination among many people with different abilities. In such systems, intelligence and cooperation become powerful tools. They allow a community to gather resources, protect itself, and adapt to changing conditions without requiring every member to possess extraordinary strength. Over time, these social and cognitive strategies may have reshaped the evolutionary pressures acting on the human body. The brain became a central organ not only for thinking but also for organizing behavior across entire groups. Tools played an increasingly important role within this system. A sharpened stone edge could cut through materials that would otherwise resist bare hands. A wooden spear could extend the reach of the arm. Fire, once controlled, could soften food and provide protection during the night. Each of these developments multiplied the effect of modest physical force. Instead of relying on muscle alone, humans began to channel their efforts through tools designed to amplify small movements. The brain guided the hands, and the hands shaped the tools that reshaped the environment. As these patterns spread across generations, the body no longer needed to invest all of its evolutionary energy into producing maximum strength. Muscles remained capable and useful, but they operated within a larger system guided by intelligence, coordination, and shared knowledge. The apparent reduction in raw muscular power may therefore reflect a deeper transformation in how humans solve the challenges of survival. Strength was not simply lost. It was redistributed within a system where the brain increasingly directed how physical effort was used. This shift would eventually lead to one of the most distinctive features of the human species, the ability to reshape the environment itself, rather than relying only on the natural abilities of the body. Long before cities rose or metals were shaped, a quieter transformation had already begun to change the relationship between the human body and the world around it. Early humans started to use tools. At first these tools were simple. A stone struck against another stone could produce a sharp edge. A broken piece of rock could slice through plant fibers or animal skin more easily than bare hands alone. A wooden branch, shaped slightly at one end, could help dig into soil or reach into narrow spaces. None of these objects were complex by modern standards. Yet even the simplest tool carried an important consequence. It allowed a small amount of physical force to produce a much larger effect. In the natural world, most animals interact with their environment, using only the structures provided by their bodies. Teeth, claws, horns, and muscles are the primary instruments through which they obtain food and defend themselves. Humans gradually developed another strategy. Instead of relying entirely on the natural strength of the body, they began to place objects between themselves and the environment. These objects could redirect, concentrate, or extend the force produced by muscles. A stone blade, for example, does not require enormous strength to cut. Its sharp edge concentrates pressure into a very small point. When that edge meets plant fibers or animal tissue, the material separates more easily than it would under blunt force alone. In this way, a modest movement of the hand can accomplish a task that would otherwise require far greater muscular effort. Archaeological discoveries reveal that stone tools appeared very early in the story of the human lineage. The oldest known examples show simple flakes created by striking one stone against another in a controlled way. Over time, these tools became more refined. Edges were shaped more carefully. Different types of tools emerged for different purposes. Some were suited for cutting meat, others helped process plant materials or scrape hides. Each improvement reflected a growing ability to guide physical force through designed objects. This development had subtle consequences for the human body. When a species begins to rely on tools, survival no longer depends entirely on the direct strength of muscles. The effectiveness of an action depends partly on the design of the tool itself. A carefully shaped stone edge may perform a task that raw strength alone cannot easily achieve. In this way, technology begins to share the burden of survival with the body. This shift does not eliminate the need for physical ability. Muscles are still required to move, to carry objects, and to apply force through tools. However, the relationship between strength and success begins to change. Instead of asking how powerful the body is on its own, survival increasingly depends on how effectively the body uses tools to interact with the environment. Early humans may not have fully understood the long-term significance of this change. To them, a sharp stone was simply a useful object that made certain tasks easier. Yet across thousands of generations, the use of tools gradually altered the evolutionary landscape. A body that could manipulate objects with precision became more valuable than one that relied only on brute strength. Hands capable of delicate control allowed tools to be shaped, repaired, and improved. In this way, the development of tools created a feedback loop. Better tools made certain tasks easier, which encouraged further refinement of tools. Each improvement increased the advantage of coordination, planning, and careful manipulation. As this process continued, the human body became part of a larger system involving hands, tools, and knowledge passed between generations. The importance of raw muscular strength did not disappear, but it began to occupy a smaller place within the overall strategy of survival. Strength remained useful, yet it no longer defined the limits of what humans could accomplish. The deeper transformation was only beginning. As tools became more common and more sophisticated, they would continue to reshape the relationship between the human body and the forces of the natural world. As tools became more common in the lives of early humans, The connection between the body and the environment slowly began to change. Before tools existed, the limits of what a creature could accomplish were largely defined by its natural anatomy. Teeth determined how food could be processed. Claws determined how objects could be grasped or torn apart. Muscles determined how much force could be applied in a single movement. These biological structures placed clear boundaries on how animals interacted with the world. The appearance of tools quietly altered those boundaries. When a shaped stone or wooden implement was held in the hand, the physical properties of that object became part of the action itself. A stone edge could be sharper than any human tooth. A wooden spear could extend the reach of the arm far beyond its natural length. A digging stick could concentrate force into the ground in ways that fingers alone could not achieve. Each tool acted as an extension of the body, transforming small movements of the hand into larger effects in the environment. This change meant that survival no longer depended only on how strong a muscle could contract. It also depended on how effectively a person could design, choose, and use the right tool for a task. Skill began to share space with strength. A carefully shaped stone blade could accomplish more than a powerful arm without one. Over many generations, this shift may have influenced the kinds of abilities that natural selection favored. Individuals capable of manipulating tools with precision may have gained advantages in obtaining food or preparing materials. Their actions did not necessarily require overwhelming physical force. Instead, they required coordination between the eyes, the hands, and the brain. This coordination allowed small adjustments in angle, pressure, and timing to guide the tool toward its intended effect. Archaeological evidence shows that tool-making itself gradually became more sophisticated. Early stone flakes were relatively simple, produced by striking one stone against another to create a sharp edge. Later tools show signs of planning in their design. Certain stones were selected for their properties. Edges were shaped deliberately to perform specific tasks. Some tools required several stages of preparation before they could be used. These developments suggest that early humans were not only using tools, but also thinking carefully about how tools worked. As knowledge about tool-making spread within groups, the benefits of these objects multiplied. A successful technique could be shared with others, allowing many individuals to produce similar tools. In this way, knowledge began to function as a resource alongside physical strength. A community that understood how to create effective tools could perform tasks that would be difficult for individuals relying solely on their bodies. This collective knowledge gradually reshaped the relationship between strength and survival. The strongest individual in a group was not always the most successful. A person skilled in tool making or tool use could obtain food efficiently even without extraordinary muscle power. Over time, the advantages associated with skill and knowledge may have influenced how the human body continued to evolve. Precision of movement, sensitivity in the hands, and coordination guided by the brain became increasingly valuable traits. The arms no longer needed to generate the same level of raw force that climbing primates relied upon. Instead, they needed to guide tools accurately and repeatedly. This transformation did not remove strength from the human body, but it redistributed its importance. The muscles of the arms still provided force, yet their effectiveness now depended on the tools they held. A modest movement applied through a well-designed object could produce results far greater than muscle alone could achieve. As tools became more integrated into daily life, the human body began to function as part of a broader system involving hands, objects, and shared knowledge. In that system, strength remained useful, but it was no longer the only path to survival. As tools became more deeply woven into daily life, their influence extended beyond simple tasks like cutting or digging. They gradually reshaped how humans interacted with the environment and with one another. A tool was not just an object held in the hand. It was a way of directing the body's effort more efficiently. Instead of pushing directly against the world with muscle alone, humans could guide their strength through objects that multiplied its effect. A sharp stone edge could separate hide from flesh with far less effort than tearing with bare hands. A wooden spear could deliver force to a target at a distance, reducing the need to overpower an animal at close range. Even a simple stick could turn the soil to uncover edible roots that would otherwise remain hidden. Each of these actions required muscle, but the tool determined how that muscle was used. The difference between success and failure often depended not on raw strength but on the design of the object and the skill of the person using it. This shift may have slowly altered the pressures shaping the human body. In environments where survival depended mainly on direct physical contests, natural selection tends to favor bodies capable of overwhelming force. But when tools enter the picture, the situation changes. A carefully shaped object can compensate for limited physical strength, allowing individuals with moderate muscles to perform tasks that would otherwise demand far greater power. Over many generations, the advantages of tool use may have reduced the evolutionary emphasis on extreme muscular strength. At the same time, the use of tools encouraged other abilities to develop. Precision in hand movements became increasingly important. The ability to hold a stone at the right angle, apply just enough pressure, and repeat the same motion again and again required fine control of muscles rather than overwhelming force. The brain and the hands worked together in a coordinated system where accuracy and timing played central roles. This pattern gradually reinforced the importance of dexterity. The human hand, already capable of delicate movements, became even more essential as tools grew more complex. Small differences in how the fingers grasped an object or how the wrist adjusted its position could determine whether a tool worked effectively or failed. Over time, this emphasis on control and coordination shaped how the upper body functioned. The arms still produced force, but their value increasingly lay in guiding tools with precision rather than simply generating power. Another quiet consequence of tool use involved learning and memory. A tool does not exist only as a physical object. It also exists as knowledge about how to create and use it. Early humans had to learn which stones fractured into sharp edges, how to strike them in the correct way, and how to maintain those edges once they became dull. These skills could be shared within a group and passed from one generation to the next. Knowledge itself became part of the survival system. When knowledge accumulates, it allows each new generation to begin where the previous one ended. Instead of rediscovering every technique from the beginning, individuals can build upon the experience of others. This process gradually increased the importance of learning and communication within human groups. Strength alone could not create such a system. It required memory, observation, and cooperation. Seen across long stretches of time, the rise of tool use represents more than a technological development. It marks a shift in how humans related to the natural forces around them. Rather than meeting every challenge with the direct power of their muscles, humans increasingly relied on tools guided by knowledge and skill. In this new arrangement, the body did not need to dominate the environment through strength alone. It needed to guide force intelligently. This transformation would soon intersect with another important feature of human life: the ability of groups to work together in ways that no single individual could accomplish alone. For most animals, survival depends largely on the abilities of a single body. An individual must gather food, defend itself, and respond to danger using its own strength and instincts. While some species form groups, their cooperation is often limited to simple coordination rather than complex shared strategies. In the human lineage, however, social life gradually developed into something far more intricate. Humans did not simply survive as individuals moving through the landscape. They survived as members of small groups that shared tasks, information, and resources. This pattern of cooperation had important consequences for how strength functioned in human life. When individuals work together, the burden of survival does not fall entirely on the physical power of one body. Instead, effort can be distributed across many people. One person may track animals across the landscape. Another may gather plants or prepare tools. Others may watch for danger or care for children. Each activity contributes to the survival of the group as a whole. In such systems, physical strength remains useful, but it is no longer the single defining factor determining success. Anthropological studies of hunter-gatherer societies provide insight into how cooperation may have shaped early human life. In many of these communities, food obtained by one individual is often shared with others. A successful hunt may provide meat not only for the hunter, but also for members of the group who did not directly participate. Plant foods gathered by different individuals are similarly combined and distributed. This sharing creates a network of mutual support that helps the group endure periods when resources are uncertain. In this cooperative environment, the survival of each individual becomes linked to the actions of others. The strongest person in the group cannot rely solely on personal ability, and the less physically powerful members still contribute in meaningful ways. Knowledge about plants, experience with tool-making, skill in navigation, or awareness of seasonal patterns can all become valuable assets to the group. These abilities do not depend on extraordinary muscular strength. Instead, they depend on memory, observation, and communication. Cooperation also allows groups to accomplish tasks that would be impossible for a single individual. Large animals may require coordinated effort from several hunters. Constructing shelters or maintaining a fire may involve multiple people working together. Even the movement of a group across the landscape requires shared decision-making about when to travel and where to stop. Through such cooperation, the physical limits of individual bodies are extended by the combined efforts of many people. Over time, this collective approach to survival may have influenced how evolution shaped the human body. When success depends partly on cooperation, the evolutionary pressure to maximize the strength of every individual may become less intense. Instead, traits that support communication, social awareness, and coordinated behavior gain importance. A body capable of moderate physical effort, combined with strong social abilities, may prove more effective within a cooperative group than one that relies only on brute strength. This does not mean that strength disappeared from human life. Lifting, carrying, and defending against danger still required physical power. However, strength operated within a broader social system rather than acting as the sole determinant of survival. In this context, the gradual reduction of extreme muscular strength becomes easier to understand. The human species was developing a strategy that relied not on the dominance of a single powerful body, but on the cooperation of many individuals working together. Within such a system, the abilities of the mind and the structure of social relationships could amplify the effectiveness of physical effort far beyond what muscles alone could achieve. Yet cooperation itself raises another question. If humans increasingly relied on group effort rather than individual strength, how did the structure of these groups influence the way human bodies and behaviors continue to evolve? When humans began to rely more heavily on cooperation, the structure of daily life slowly shifted away from the model seen in many other animals. Instead of each individual depending entirely on personal strength, survival increasingly involved the coordination of many different abilities within a group. This change did not happen all at once. It emerged gradually as human communities developed patterns of shared work, shared knowledge, and shared responsibility for survival. In such communities, different individuals could specialize in different tasks. Some members of the group might be particularly skilled at tracking animals across the landscape. Others might excel at shaping stone tools or recognizing edible plants among many similar species. Some might become especially attentive observers of weather patterns or seasonal changes in animal movement. These skills often depend less on brute force and more on memory, patience, and experience. When these abilities are combined within a group, the effectiveness of the entire community increases. This kind of social organization creates a form of collective strength that is very different from the physical power of a single individual. Instead of relying on one exceptionally strong body to solve every problem, the group distributes effort across many people. One person's weakness in one area can be balanced by another person's strength in a different area. Over time, this pattern of cooperation may have influenced the kinds of traits that natural selection favored in the human lineage. Individuals who are attentive to others, capable of communication, and able to coordinate actions within a group may have had advantages in survival. These social abilities require a different set of biological foundations than raw muscular power. They depend on the brain's capacity to interpret signals, remember past interactions, and anticipate the behavior of others. The human brain, already growing in size and complexity, became increasingly involved in managing these social relationships. Communication played a crucial role in this process. Early forms of language or symbolic gestures allowed individuals to share information about the environment. A discovery made by one member of the group could benefit many others. Knowledge about water sources, food locations, or potential dangers could spread through conversation and observation. This exchange of information reduced the need for every individual to learn everything through direct physical experience. A group could respond to challenges more efficiently when information moved quickly between its members. Within this environment, strength still had value. Carrying food back to camp, helping construct shelters, or defending the group against threats required physical effort. However, the outcome of many situations depended on the coordination of several individuals rather than the dominance of one. A group working together could accomplish tasks that no single person could manage alone, even if that individual possessed extraordinary strength. This collective ability gradually reshaped the meaning of power within human communities. Power was no longer measured only by how much force a body could produce. It also included the ability to guide group behavior, remember important details about the environment, and cooperate effectively with others. These forms of influence often depended on cognitive and social skills rather than physical strength. Over many generations, such patterns may have altered the pressures shaping the human body. Natural selection does not operate with a specific goal in mind. Instead, it favors traits that increase the chances of survival within a given environment. In a world where cooperation and communication play central roles, the evolutionary advantage of extreme muscular strength may gradually diminish. The body remains capable of physical work, but it does not need to invest all of its resources into maximizing force. As the human lineage continued to evolve within cooperative groups, strength became one element among many in a complex system of survival. The body, the brain, and the social structure of the group worked together to navigate the challenges of the environment. Yet cooperation within a group also introduced a new dimension to human life. Once knowledge and effort were shared across generations, the passage of time itself began to influence how humans survived and adapted. As cooperation became a stable feature of human life, another quiet transformation began to shape the way human groups functioned. Survival was no longer determined only by what a single individual could accomplish during one lifetime. Knowledge, experience, and skills could now accumulate across generations. In many animal species, individuals rely mostly on instinct or behaviors learned within a short period of time. When those individuals disappear, much of their experience disappears with them. Human communities gradually developed a different pattern. Information about the environment, about food sources, about tools, and about safe routes through the landscape could be shared and remembered. Children did not begin life without guidance. They observed the actions of older members of the group and slowly learned how to survive in their surroundings. This process of learning extended childhood and deepened the connections between generations. The presence of older individuals within the group became increasingly valuable. People who had lived longer carried knowledge that younger members had not yet acquired. They remembered where water might still be found during dry seasons. They recognized patterns in animal movement that only became clear after many years of observation. They understood how to repair tools or prepare materials that younger individuals were still learning to handle. This accumulated knowledge could help the entire group navigate uncertain conditions. In such systems, physical strength was not the only measure of value. An older person might not possess the same muscular power as a young adult, yet their experience could guide the decisions of the group. Knowing when to move to a new location, how to avoid a dangerous area, or how to recognize a subtle sign in the environment could be just as important as lifting heavy objects or running quickly. This shift placed increasing importance on the brain's ability to remember, interpret, and communicate information across time. Social bonds also deepened under these conditions. Cooperation required trust between individuals. Food sharing, collective movement, and coordinated tasks depended on the expectation that members of the group would support one another. Over time, human communities developed social behaviors that strengthened these relationships. Caring for children, assisting injured individuals, and maintaining shared resources all reinforced the stability of the group. These behaviors did not depend primarily on physical strength. They depended on empathy, communication, and the ability to understand the needs of others. The human brain became increasingly involved in managing these complex social dynamics. Interpreting facial expressions, remembering past interactions, and predicting the behavior of others required cognitive abilities far beyond simple instinct. The brain that had already grown larger during earlier stages of human evolution continued to play a central role in these social systems. Within this environment, the meaning of strength continued to evolve. Strength was no longer limited to muscle alone. It included the capacity of groups to coordinate their actions, the ability of individuals to share knowledge, and the resilience of communities that could adapt to changing conditions. The body remained an essential tool for survival, but it functioned within a network of relationships and shared understanding. As generations passed, these patterns reinforced the idea that human survival depended on more than the power of a single individual. The group itself became a form of strength. Each person contributed a different set of abilities, and together those abilities allowed humans to face challenges that would overwhelm isolated individuals. Seen from this perspective, the gradual reduction of extreme muscular strength does not appear as a simple loss. Instead, it reflects the emergence of a new strategy for survival, one rooted in cooperation and shared knowledge. This strategy would soon interact with another powerful force shaping human evolution: the vast landscapes through which early humans continued to travel. For much of human history, survival unfolded across vast landscapes. Early humans did not live within fixed borders or permanent settlements. Their lives were shaped by movement through environments that could stretch for many kilometers in every direction. Rivers shifted with the seasons. Herds of animals followed changing patterns of vegetation. Plants appeared and disappeared depending on rainfall and temperature. In such a world, the ability to move across space became one of the quiet foundations of survival. The human body carries many signs of adaptation to this kind of life. Long legs relative to body size allow humans to cover ground efficiently. The alignment of the spine above the hips supports upright posture for extended periods of walking. The structure of the feet provides stability and energy conservation with each step. These features together form a system designed not for sudden bursts of force but for sustained travel across open terrain. Movement across large areas also changed the way humans interacted with the environment. Instead of relying on a single location for food, early humans explored territories that contained many different types of resources. A group might gather fruit in one area during a particular season and move elsewhere when those resources became scarce. Water sources might require travel across dry ground. Animals might migrate across wide plains. To survive within such landscapes, humans needed to maintain a steady rhythm of movement that could continue for hours or even days. This constant movement favored bodies capable of endurance. A creature built primarily for explosive strength might perform well in brief contests but struggle when required to travel long distances repeatedly. Humans appear to have followed a different evolutionary path. Their bodies became capable of maintaining moderate effort for extended periods without exhausting their energy reserves too quickly. Even the structure of the human skin reflects this adaptation. The ability to release heat through sweating helps regulate body temperature during long periods of activity. When muscles work continuously, they generate heat that must be dissipated to prevent overheating. By allowing sweat to evaporate across the surface of the skin, the human body can continue moving even in warm conditions that might force other animals to stop and rest. Over time, this ability may have allowed humans to travel during parts of the day when other animals were less active. The landscape itself also shaped how strength functioned within the human body. In dense forests, climbing and pulling might dominate daily movement. In open savannas or woodlands, the challenge often lies in crossing large distances while conserving energy. The human body appears to have adapted increasingly toward this second pattern. Instead of emphasizing extreme upper body strength for climbing, it emphasized leg-driven locomotion capable of sustaining long journeys. These journeys were rarely undertaken alone. Small groups moved together through familiar territories, sharing information about the locations of food, water, and shelter. Knowledge about the landscape became an important survival tool. Paths through the terrain were remembered and passed from one generation to the next. Certain locations might provide resources during specific seasons, while others served as temporary resting places during long journeys. The ability to navigate these landscapes depended on memory, observation, and communication within the group. In such conditions, the advantages of endurance became clearer. A group capable of traveling farther could explore new territories when local resources became scarce. They could adapt more easily to environmental changes and avoid dangers by moving to safer locations. Strength remained useful, especially for carrying resources or handling tools, but it was no longer the dominant trait shaping how humans survived. Instead, survival increasingly depended on how effectively humans could move across space and adapt to the shifting patterns of the environment around them. The vastness of these landscapes quietly reinforced the evolutionary trends already shaping the human body. As generations passed, the human lineage became more deeply adapted to life defined by movement across distance. Yet this long relationship with space also raises another question. If humans evolved to travel through such wide territories, how did the passage of time and the expansion of human history continue to reshape the human body itself? As human groups continued to move across wide territories, the relationship between the body and the landscape became increasingly refined. Survival did not depend on reaching a single destination as quickly as possible. Instead, it depended on the ability to navigate environments that changed gradually over time. Rivers could shift their courses, vegetation could expand or retreat depending on rainfall. Animals followed patterns of migration that might repeat each year but still required careful observation to track. In this dynamic setting, humans developed a style of movement that balanced patience with persistence. Rather than relying on bursts of speed or sudden displays of power, early humans often moved at a steady pace that could be maintained for long periods. This rhythm allowed groups to travel across uneven terrain while conserving energy. It also allowed individuals to remain attentive to subtle details in the environment, such as animal tracks, changes in vegetation, or signs of water hidden within the landscape. The human body appears well suited to this style of movement. The legs act as the primary engines of locomotion, supported by muscles capable of repeating the same motion thousands of times without failing. Tendons store small amounts of energy with each step and release it again during the next movement. The result is a form of travel that may not appear powerful in any single moment, but becomes effective over distance and time. This pattern of movement shaped how humans encountered resources. Food was rarely concentrated in one place for long. Edible plants might appear briefly after rainfall and then disappear again as conditions changed. Animals moved across large areas in search of grazing land or water. To keep pace with these shifting resources, human groups needed to maintain flexibility in where and when they traveled. Endurance allowed them to follow opportunities across the landscape rather than remaining confined to a single location. This mobility also influenced how human communities organized their daily activities. A day's journey might involve walking many kilometers while scanning the ground for edible plants or signs of animal movement. Rest periods might occur in shaded areas where water or shelter could be found. At night, groups might settle temporarily before continuing their movement the following day. Over time, such rhythms of travel became deeply integrated into the structure of human life. These patterns of mobility also interacted with the social nature of human groups. Traveling together required coordination. Decisions about direction, timing, and rest had to consider the needs of multiple individuals within the group. Children, older members, and adults with different physical abilities all contributed to the shared journey. Cooperation ensured that no single person carried the entire burden of survival alone. Strength still played a role in this system. Carrying gathered food, transporting tools, or assisting others during difficult terrain required physical effort. However, the success of the group depended less on the extreme strength of a few individuals and more on the sustained effort of many people moving together across the land. Endurance allowed each member of the group to contribute over time, creating a form of collective resilience that extended beyond individual physical limits. In such conditions, the advantages of explosive strength become less central. A creature capable of extraordinary force might dominate brief encounters but struggle to maintain the steady pace required for long journeys. Humans appear to have evolved in the opposite direction. Their bodies support movement that can continue hour after hour, day after day, without rapidly exhausting their energy reserves. The landscape itself reinforced this evolutionary pattern. As generations passed, the ability to travel across distance became part of the human identity. The body adapted to environments where survival required patience, observation, and persistence rather than domination through brute force. Yet the passage of time brought additional changes. As human populations expanded and environments shifted across thousands of years, the body itself continued to evolve in response to new challenges and opportunities. Across many thousands of years, the movement of human groups across wide landscapes left quiet traces in both archaeology and biology. Tools, fragments of hearths, and scattered remains of camps appear in locations separated by large distances. These traces suggest that early humans were not confined to narrow territories. Instead, they traveled through environments that could stretch across valleys, plains, and river systems. The rhythm of life unfolded through cycles of movement, where people returned to familiar places during certain seasons and moved onward when conditions changed. In such a way of life, the human body functioned as a vehicle for exploration. The legs carried individuals across uneven ground, through grasslands, and along riverbanks. The feet absorbed the impact of thousands of steps while maintaining balance over rocks and soil. Each day of travel reinforced the importance of a body capable of maintaining steady effort rather than producing brief bursts of extreme strength. Over time, these patterns of movement shaped how humans experienced the world around them. The landscape was not simply a backdrop for survival, it was an active participant in the evolutionary process. The distance between water sources, the location of edible plants, and the seasonal behavior of animals all influenced how far and how often humans needed to travel. In environments where resources were scattered, endurance became a practical advantage. A group able to move farther could reach new sources of food or escape regions where conditions had become difficult. This relationship between movement and survival also influenced how knowledge was shared within human communities. The routes taken across the land were rarely random. Certain paths might follow rivers that provided water and shade. Others might lead toward areas where plants grew after seasonal rains. Over time, these routes became part of the memory of the group. Older individuals might remember where a particular valley provided shelter during storms, or where a distant plain offered abundant grazing animals during a specific season. Such memories allowed groups to navigate large territories with confidence. Knowledge of the landscape, therefore, worked together with the body's ability to travel across it. Strength alone could not reveal where food might appear next month, or which direction offered the safest passage through unfamiliar terrain. These insights depended on observation, experience, and communication among members of the group. In this system, the body provided endurance while the mind provided guidance. Together, they allowed humans to move through environments that might otherwise seem overwhelming. The demands of these journeys also reinforced the shift in how strength functioned within the human body. Muscles still needed to support the work of walking, carrying, and using tools. However, the body did not need to maximize the kind of explosive force used by animals that depend on sudden attacks or intense physical contests. Instead, muscles were organized to support repeated effort over long periods. This form of strength appears less dramatic than a sudden display of power, yet it allows a body to remain active across the changing rhythms of the natural world. Seen across the deep timeline of human history, the landscapes through which humans traveled played a quiet role in shaping the species. The wide spaces of plains, forests, and river valleys favored bodies capable of patience and persistence. These environments rewarded groups that could combine endurance with knowledge of the land. As these patterns continued over countless generations, the human body became increasingly adapted to a world defined not by a single moment of strength, but by the steady movement of life across distance and time. Yet the transformation of the human body did not stop with movement alone. The passage of generations would continue to shape how human strength appeared, gradually revealing the long-term changes written into the bones and muscles of the species. When scientists study the story of human strength, they rarely rely on a single piece of evidence. Instead, they examine many kinds of traces left behind across time. Fossil bones, archaeological tools, and the structure of the modern human body all provide clues about how physical abilities changed throughout human evolution. These traces do not present a dramatic moment when strength suddenly disappeared. Rather, they reveal a gradual transformation unfolding across hundreds of thousands of years. One of the most informative sources of evidence lies in the skeleton. Bones carry marks of how muscles attach and how forces move through the body. When muscles pull repeatedly on certain areas of bone, those areas can become more pronounced over time. By comparing the skeletons of early human ancestors with those of later humans, researchers can observe subtle differences in how the body was structured and used. Some early members of the human lineage appear to have had more robust upper bodies than modern humans. Their arm bones show signs of strong muscle attachments, suggesting that climbing and heavy physical work may have played a larger role in their daily activities. At the same time, their lower bodies already show adaptations for upright walking. This mixture of traits reflects a transitional phase in which the human lineage was still balancing abilities inherited from tree-dwelling ancestors with new demands emerging on the ground. As time progressed, and new species of humans appeared, the skeleton continued to change. In later humans, including modern Homo sapiens, the body often appears more slender and less heavily built than in some earlier relatives. The bones of the arms and shoulders tend to show less extreme reinforcement from muscle attachments associated with climbing or pulling. Meanwhile, the lower body remains adapted for upright locomotion. These patterns suggest that the role of extreme upper body strength may have gradually diminished as other abilities became more important. Archaeological evidence complements these observations. The increasing presence of tools in the archaeological record indicates that humans relied more heavily on technology to interact with the environment. As tools improved, tasks that once demanded significant physical force could be performed with greater efficiency. A cutting-edge organs made from stone could process materials more easily than hands alone. Fire could soften food and reduce the effort required to chew and digest certain resources. Each of these developments subtly altered the physical demands placed on the human body. Another line of evidence comes from the comparison between modern humans and our closest living relatives among the great apes. Chimpanzees and other apes possess upper bodies designed for powerful climbing and pulling. Their muscle distribution and skeletal structure reflect a life spent navigating trees and engaging in bursts of intense strength. Humans, by contrast, show a body plan that favors endurance and coordination over raw pulling power. This difference does not mean that humans are incapable of strength. Rather, it highlights the different evolutionary paths taken by species that face different environmental challenges. The archaeological and biological records together tell a consistent story. Human strength did not vanish at a single moment in history. Instead, it gradually shifted as the human lineage adopted new strategies for survival. Upright walking redistributed the work of movement toward the legs. Endurance became a valuable trait in landscapes where resources were scattered. Tools allowed modest physical force to produce greater effects. Cooperation within groups distributed effort across many individuals rather than concentrating it in one powerful body. Each of these changes left subtle marks on the human skeleton and behavior. Over long periods of time, these marks accumulated into the physical pattern we recognize today, yet the transformation of the human body is still not complete. Even within recent human history, the ways people live, work, and move continue to influence how strength appears in daily life. The gradual transformation of the human body did not stop once modern humans appeared. Even within the relatively recent chapters of human history, the structure of the body continued to reflect changing ways of life. Archaeologists studying ancient skeletons have noticed patterns suggesting that earlier human populations were often more physically robust than many people living today. The bones of prehistoric individuals frequently show strong muscle attachments and signs of regular physical activity. These features indicate that daily life once required consistent physical effort. Carrying water, gathering wood, shaping tools, traveling long distances, and preparing food all place demands on the body that modern environments rarely require in the same way. This observation does not mean that ancient humans were universally stronger than modern people in every sense. Instead, it reflects differences in lifestyle. When the tasks of daily survival involve continuous physical labor, muscles and bones respond by strengthening through repeated use. The body adapts to the activities it performs most often. Over many years, these patterns of movement leave visible traces in the skeleton. In contrast, many modern environments reduce the need for such constant physical effort. Tools, machines, and built infrastructure perform many of the tasks that once required sustained human labor. The body still possesses the capacity for strength and endurance, but it may not always be used in the same ways as in earlier periods of human history. These recent changes in lifestyle can sometimes create the impression that humans have suddenly become weaker. In reality, the deeper evolutionary patterns remain visible beneath these differences. The human body continues to show the features that developed across much longer timescales: upright posture, endurance-oriented movement, and hands capable of precise manipulation. These traits were shaped long before the appearance of agriculture, cities, or industrial technology. Fossil and archaeological records suggest that the shift away from extreme upper body strength had already occurred long before the modern era. The bodies of early humans were adapted for travel across landscapes, cooperation within groups, and interaction with tools. These adaptations allowed the species to expand across diverse environments on multiple continents. When humans moved into new regions, they encountered climates and terrains very different from the African landscapes where their ancestors had evolved. Some populations adapted to cold conditions, others to high altitudes or dense forests. Yet the underlying structure of the human body remained consistent. It continued to emphasize endurance, coordination, and cognitive flexibility rather than maximum muscular force. The archaeological record also reveals the increasing complexity of human culture over time. Tools became more specialized, shelters more carefully constructed, and social networks more extensive. Each of these developments further reduced the need for individuals to rely solely on physical strength when interacting with their environment. Knowledge, communication, and cooperation increasingly shaped how humans solved problems. This gradual accumulation of cultural and technological strategies reinforced the evolutionary trends already present in the human body. Strength remained useful, but it was no longer the defining trait that determined success. The human species had developed another path for survival, one that combined physical ability with intelligence, shared knowledge, and adaptability. From this perspective, the question of why humans lost much of their raw strength becomes less mysterious. The change was not a sudden decline or a biological failure. It was the result of many interconnected shifts in how the human body functioned within its environment. Yet understanding this transformation also invites a deeper reflection. If humans gradually moved away from relying on brute force, what exactly did the species gain in return for that exchange? When the long arc of human history is examined through fossils, tools, and the structure of the modern body, a consistent pattern begins to emerge. The transformation of human strength was not a sudden loss, nor was it the result of a single change. Instead, it unfolded through many small adjustments that accumulated across immense stretches of time. Each generation inherited a body already shaped by earlier evolutionary decisions. Over thousands of generations, these inherited traits slowly shifted in response to changing environments and new ways of living. Fossil bones provide quiet testimony to this process. Early members of the human lineage often display skeletal features that suggest a more physically robust upper body than many modern humans possess today. Their bones show thicker shafts and more pronounced areas where muscles once attached. These features likely reflect the physical demands of their daily activities, which included climbing, moving across uneven terrain, and manipulating natural materials without the assistance of advanced tools. Yet even within these early populations, the skeleton already carried signs of change. The legs and hips show clear adaptations for upright walking, and the proportions of the body begin to move away from those of tree-dwelling primates. Over time, later human populations reveal a gradual shift toward lighter skeletal structures. This pattern does not indicate weakness in a simple sense. Instead, it suggests a body increasingly adapted to efficiency and endurance rather than raw muscular power. A lighter frame can move across long distances with less energy expenditure, especially when combined with the anatomical features supporting upright locomotion. Archaeological discoveries help illuminate how these physical changes interacted with cultural developments. As tools became more refined and social cooperation more complex, the demands placed on the body began to change. Tasks that once required great physical effort could sometimes be accomplished through carefully designed tools or coordinated group activities. The body did not need to carry the entire burden of survival alone. Instead, it functioned within a network of technologies and relationships that extended its capabilities. The emergence of fire, for example, altered how humans processed food and interacted with their environment. Cooking could soften certain foods and make them easier to consume and digest. This process did not directly remove strength from the body, but it changed how energy flowed through daily life. As food preparation and tool use evolved, physical effort could be directed more efficiently towards specific tasks rather than constant raw exertion. These cultural changes reinforced the evolutionary direction already shaping the human body. When survival depends partly on knowledge, planning, and cooperation, the selective pressure for extreme muscular strength may gradually decrease. Traits supporting endurance, coordination, and cognitive ability continue to provide advantages in such environments. Across the deep timeline of human evolution, these pressures combine to produce a species whose physical abilities differ from those of its closest relatives. Humans may not possess the explosive strength of chimpanzees or other powerful animals, but their bodies reflect a different set of priorities. The human form supports long-distance movement, fine manipulation of objects, and the coordination of complex behaviors guided by the brain. The archaeological and biological records therefore tell a story not of decline, but of transformation. Strength did not simply vanish from the human body. It was integrated into a broader system where endurance, intelligence, and social cooperation played equally important roles. Seen in this way, the apparent loss of raw power becomes part of a larger evolutionary exchange. The human lineage did not abandon strength without gaining something in return. Instead, the body gradually reorganized itself around a new strategy for survival. And this long transformation leads naturally to one final question. If humans gave up a significant portion of their physical strength across millions of years, what exactly did they gain in exchange for that change? Across the long timeline of human evolution, the gradual shift away from extreme muscular strength begins to look less like a loss and more like a transformation. The human body did not simply become weaker. Instead, it reorganized its abilities around a different strategy for surviving in a complex and changing world. Muscles remained important, but they no longer carried the entire burden of interacting with the environment. Other abilities slowly joined them in shaping how humans lived and adapted. One of the most significant of these abilities was the growing capacity of the human brain. As the brain expanded and became more complex, it allowed humans to observe patterns, remember past experiences, and plan future actions. Instead of relying solely on immediate physical responses, humans could anticipate changes in their environment and respond with preparation rather than reaction. This shift altered how problems were solved. A challenge that might once have required direct physical force could sometimes be addressed through observation, cooperation, or the use of tools. The human body also gained an unusual level of coordination between its different systems. Muscles, senses, and the nervous system worked together to guide precise movements. Hands could manipulate objects with remarkable control. Eyes could detect subtle changes in the environment. The brain could combine these signals to guide actions that required patience and accuracy. Such coordination allowed humans to shape tools, construct shelters, and interact with their surroundings in ways that extended far beyond the limits of raw strength. Another important gain was flexibility in behavior. Many animals follow highly specialized patterns shaped by their physical traits. A predator built for speed depends on speed to capture prey. A climber built for powerful arms depends on trees for movement. Humans, by contrast, develop the ability to adapt their strategies across different environments. The same body that could travel across open plains could also move through forests, along rivers, or across mountainous terrain. This flexibility came partly from the body's endurance and partly from the brain's capacity to learn and share information. Social cooperation amplified these advantages even further. Groups of humans could coordinate their efforts, share resources, and support one another during difficult periods. Knowledge passed from one generation to the next created a collective memory that extended beyond the experience of any single individual. Within such communities, survival depended on a network of relationships rather than the strength of a single body. The effectiveness of the group could exceed the physical limits of its individual members. Tools and technology added another layer to this system. A stone blade, a wooden spear, or a controlled fire allowed humans to direct their physical effort more efficiently. Instead of relying on muscles alone, humans could apply modest force through carefully shaped objects that multiplied its effect. Over time, this relationship between body and tool became one of the defining features of the human species. When these elements are viewed together, the apparent reduction in raw muscular strength takes on a different meaning. The human body gradually shifted toward endurance, coordination, and adaptability, because those traits worked well with intelligence, cooperation, and technology. The species did not abandon strength entirely, but it placed that strength within a broader framework of abilities. This transformation allowed humans to survive in environments that would challenge many other animals. It allowed them to travel across continents, adapt to changing climates, and build communities capable of passing knowledge across generations. In this sense, the story of human strength is not only about what was lost, it is also about what was gained through a long evolutionary exchange. Yet even with these advantages, the human body still carries traces of the ancient past. The bones, muscles, and movements of modern humans remain connected to the deep history of the species, and within that history lies a quiet reminder that the human body was never designed to dominate the world through strength alone. When the story of human strength is viewed across millions of years, the changes in the human body begin to resemble a long process of rebalancing rather than a simple decline. Muscles did not disappear, and humans did not become incapable of physical effort. Instead, the body slowly shifted the way its energy and structure were used. Evolution rarely creates perfect solutions. It works through compromises, adjusting existing traits in response to new conditions. In the case of humans, these adjustments gradually moved the species toward a form of survival that depended less on overwhelming physical force and more on coordination between body, mind, and environment. One important element of this balance lies in how energy is used within the human body. Maintaining muscle tissue requires constant biological investment. Muscles consume energy even when they are at rest, and larger muscles require more resources to sustain. At the same time, the human brain is one of the most energy-demanding organs in the body. Although it represents a small portion of total body weight, it uses a significant share of the body's daily energy supply. Across evolutionary time, the expansion of the brain may have influenced how energy was distributed throughout the body. Resources directed towards supporting a larger brain might have reduced the advantage of maintaining extremely large muscles when other survival strategies were available. This does not mean that strength and intelligence directly replaced one another in a simple trade. The relationship is more subtle. When the brain allowed humans to solve problems through planning, cooperation, and tool use, the selective pressure for extreme muscular power may have become less intense. In environments where intelligence and social coordination improved survival, bodies that balanced moderate strength with endurance and cognitive ability could thrive. Over many generations, this balance became characteristic of the human species. Another aspect of this transformation appears in how humans interact with their surroundings. Rather than confronting the environment through direct physical dominance, humans learned to reshape it. Simple shelters protected groups from harsh weather. Fire created warmth and allowed food to be prepared in new ways. Tools expanded the reach of the human hand, allowing modest force to achieve greater results. Each of these developments reduced the need for raw strength while increasing the effectiveness of human action. The body therefore functioned as part of a larger system that included knowledge, technology, and cooperation. Social life also played a role in shaping this balance. Within human communities, survival often depended on the collective effort of many individuals. Children required care for long periods while they learned the skills necessary for adulthood. Older individuals contributed knowledge and guidance gained through years of experience. These relationships created networks of support that allowed the group to survive even when some members were not at their physical peak. In such systems, the value of individuals could not be measured by strength alone. Memory, teaching, and cooperation became equally important forms of contribution. Seen from this perspective, the human body reflects a strategy that prioritizes adaptability over specialization. Many animals achieve success by perfecting a single powerful trait, whether it is speed, strength, or camouflage. Humans appear to have followed a different path. Their bodies support many moderate abilities rather than one extreme specialization. Endurance, coordination, communication, and learning all combine to form a flexible system capable of responding to unpredictable challenges. This flexibility may explain why humans eventually spread across nearly every continent on Earth. The species did not dominate through overwhelming strength, but through the ability to adjust behavior and share knowledge across generations. The human body therefore represents a long history of compromise and adaptation. Strength remained present, but it was integrated into a broader network of abilities that allowed humans to navigate a complex world. And as the final chapters of this story approach, one quiet question remains. What does this long transformation reveal about the nature of being human itself? If the long story of human evolution is followed from its distant beginnings to the present day, one pattern becomes increasingly clear. The human species did not become successful by perfecting one overwhelming physical ability. Instead, humans gradually assembled a combination of many moderate abilities that could work together. Strength remained part of this system, but it was no longer the defining feature that determined survival. The body, the brain, and the social structure of human communities slowly formed an interconnected network that allowed the species to adapt to environments across the planet. In the earliest phases of the human lineage, physical strength likely played a more central role in daily survival. Climbing, pulling, carrying, and manipulating natural materials all required powerful muscles. The skeletal evidence from early ancestors suggests bodies that were more heavily built than those of most modern humans. Yet even within those ancient bodies, another trajectory was already emerging. Upright walking, long-distance travel, and the gradual expansion of the brain were quietly reshaping how the human body functioned. These changes did not remove strength, but they altered the balance between different abilities. As generations passed, humans began to rely more heavily on endurance, coordination, and cooperation. The body became capable of traveling across wide landscapes while conserving energy. Hands became tools for shaping objects rather than instruments for climbing branches. Communication allowed knowledge to move between individuals, making survival less dependent on the physical capacity of a single body. Each of these developments shifted the evolutionary pressures acting on the human form. Instead of selecting for extreme muscular power, natural selection increasingly favored bodies that could sustain activity, interact with tools, and function within complex social groups. Over immense periods of time, these pressures produced the body that modern humans recognize today. It is a body that may appear physically modest when compared with the powerful musculature of some other animals. A chimpanzee, for example, can produce remarkable bursts of force relative to its size. Yet the human body carries a different set of strengths that are less obvious but equally important. Humans can travel long distances without exhausting themselves. They can coordinate movements with remarkable precision. Their hands can manipulate materials to create tools that multiply the effect of physical effort. These abilities extend the reach of the body far beyond what muscles alone could achieve. The deeper message of this evolutionary story lies not in the idea that humans lost something valuable, but in the realization that the species transformed its relationship with strength. Physical force became only one element within a larger system that included intelligence, culture, and cooperation. The human body functions most effectively when these elements work together. Muscles provide the capacity to act. The brain guides those actions, and social networks allow knowledge to accumulate across generations. When these pieces combine, the result is a form of power very different from brute strength. This form of power allowed humans to survive ice ages, cross continents, and build communities that shared knowledge across thousands of years. It allowed individuals with different abilities to contribute to the survival of the group. Even people who were not physically strong could pass on knowledge, guide decisions, and help shape the future of the community. In this way, the apparent reduction of extreme muscular strength may have opened space for other qualities to flourish within the human species. Patience, cooperation, memory, and creativity gradually became just as important as physical force. The story of human strength therefore ends with a quiet reminder. The human body was never meant to dominate the natural world through muscle alone. It was shaped to work together with the mind and with other humans. And when the long arc of human history is viewed in this light, the question that began this journey remains gently open. If humans gradually lost much of their raw strength, what does that reveal about the kind of strength that truly defines our species?